from rethinking invention to maybe reframing what Made in Africa is all about, I'm going to introduce Dr. Lucia Corsini. She'll be speaking on behalf of collaborators Mr Mayamiko Nkoloma in Malawi and Dr Seifu A Tilahun, who's in Ethiopia. So, Lucia, over to you.
Hello. So it's a real honor to be here today. So hopefully if we get the slides up. As was just said, I'm presenting today on behalf of a much broader team. So colleagues in Malawi and Ethiopia. And I wanted to start by actually showing this video that colleagues have put together of our project looking at digital fabrication of PPE in Malawi and Ethiopia. So I think we can start with this and then I'll talk more about the project.
At the start of the COVID-19 pandemic, global shortages of PPE became widespread.
When COVID just started, many hospitals were struggling to get hold of the available PPEs. So we all were scrambling in town to the few pharmacies that had the PPEs. And besides the availability, that was a challenge. The cost also was very high. So our hospital is big. We actually struggled so much to satisfy the need that we had at the time.
Engineers around the world started looking for solutions. In Malawi, Maya Nkoloma from the University of Malawi, the Polytechnic, started experimenting with 3D printing face masks. In Ethiopia, Henok Mibrati from BIT Makerspace was also testing ways to 3D print PPE to meet urgent demand. However, the lack of available equipment and tools was preventing teams in Malawi and Ethiopia from scaling up their production. In response, a collaboration was established between researchers and practitioners based in the UK, Ethiopia, and Malawi. In total, 18 3D printers and 2 laser cutters were supplied to teams in Malawi and Ethiopia. In Malawi, a new digital fabrication facility was established at 20 Makerspace. In Ethiopia, digital fabrication tools were embedded at BIT Makerspace. 2 weeks after setting up 20 Makerspace, 2,000 face shields were produced and donated to the largest public hospitals in Malawi. Over 3,000 face shields were sold to local SMEs, and 160 face shields were donated to local primary schools. At BIT Makerspace, over 3,000 face shields were donated to local hospitals, cafeteria workers, and staff on the BIT campus.
We have been doing with Bahir Dar Institute of Technology. They have been so much helpful, especially by delivering face shields. So far we have found it very useful and in good shape and good quality.
Overall, both projects provided employment to over 25 people, including digital fabrication training for 40 people.
When I joined here, it was a time of COVID. I was forced to learn more about engineering designs, mostly AutoCAD as well as SolidWorks. So it really boosted my career aspirations as an engineer in terms of designing. And at the very same time, knowing that we are solving real-world problems, like pertaining to COVID, we are producing face shields as well as face masks. It really gave me that industrial feel that as an engineer, I can really solve problems, not only in my aspect of engineering as well as in the health sector. I've learned also more about machine operations, the machines which I never knew I could work with. The likes of the 3D printers, we have the CNC, the laser cutter. Those were machines which were new and we never had the experience feel of them at school.
At BIT, the 3D printers and laser cutter are still in constant use. In the future, both BIT and 20 aspire to provide a platform for aspiring entrepreneurs to develop solutions to local social and sustainability challenges.
So here at 20 Makerspace, I think you have seen, we work with the young minds. So this place, we've more like created it as a hub, as a center where people can come and learn entrepreneurial skills or new technologies which they can use and start building things on their own wherever they stay. So we started with small numbers, but as of now, not less than 60 youths have passed through the hub by learning or contributing their skills to our initiatives.
Great, so we're really grateful to Cambridge Africa for supporting these two COVID-19 response projects. So you saw some of the wider team there, but these are some of the researchers and practitioners based in the UK, Malawi and Ethiopia, that without whom this project just could not have been possible. I actually wanted to start by going a little bit into the backstory of this project and my personal connection to looking at digital fabrication and crisis critical products. And this photo I put here was taken 2 weeks before the WHO announced that COVID-19 was a pandemic. And I just handed in my PhD thesis, which was looking at how digital fabrication tools such as 3D printing or laser cutting or CNC milling, how they could be used to help solve humanitarian health and development challenges in low and middle income countries. And to tell you a little bit more about some of the kind of broad applications of these technologies, there are three kind of major rationales for using these technologies, and it could be for the use of highly customized parts such as prosthetics, for standard parts that need to be manufactured more locally. So here is an example taken from Gaza with the 3D printing of tourniquets. So in an area that's blockaded and it's incredibly hard to import supplies, or for molds and tooling, so the digital fabrication tools can just be used as one part of a broader production process. And so the main rationales then for using these technologies is that you can shift supply chains from these very centralized supply chains to more local supply chains. And that in turn enables more contextually appropriate solutions because you're bringing the design and the manufacturing process closer to the users. But you're also able to bypass some of the supply chain challenges and also that in turn benefit the local community and result in these socioeconomic benefits. What I found when I was doing my PhD was that there was this gap between the potential of these type of projects and then what was happening in reality on the ground. And so that's why I was trying to codify some of the best practices that I saw and to develop frameworks for supporting people who are working on these projects. And I won't go too much into detail, but I looked at this from two different perspectives. One, this very analytical design perspective that tried to look at the world as a complex system and break it down into parts and to codify some of the best practice. And then on the other hand, really embracing complexity and looking at these complex socio-technical systems to understand the relationships between people and technology. This is a summary that I'll come back to a little bit later, but these were 16 factors that were distilled from this research and identified as being really critical for ensuring the long-term sustainability of these projects. And some of these factors are very much related to the product design, some are more process-related, and then some are really talking about the broader system as a whole, or what are labelled here as paradigm factors. And this has been developed into an interactive toolkit by the H2H network. So it's a guideline for planning and evaluating digital fabrication projects in the humanitarian development sector. So as I mentioned, I handed in my PhD just before pandemic, and I had plans to continue this research looking at the distributed manufacturing of medical products in low-income countries. And then COVID hit, and suddenly I realized that this research had a very time-critical importance to it, and we were supported by the Cambridge Africa Fund with 2 COVID-19 emergency awards. So as you saw in the video, at this time there were huge shortages of PPE around the world, and there was this emerging opportunity of looking at how digital fabrication could be used to localize the production of PPE, such as face masks and face shields. So I was already working with BIT in Ethiopia, and then through the Cambridge Africa Network was put in touch with Maya and his team in Malawi, and we formed this UK, Malawi, and Ethiopian network involving partners from those 3 countries. And the challenge that we had was there weren't any in Malawi. There were no 3D printers or digital fabrication tools actually embedded in the country already that we could tap into. So we were looking at how we could rapidly deploy these digital fabrication tools and set up what we now call 20 Makerspace as a local distributed manufacturing hub to manufacture these face masks and face shields. And in Ethiopia, BIT had actually opened its doors a few months before the pandemic had started, so there were some machines there, but it was still very much in its infancy. But through this project, we were able to supply and expand machines and expand the facilities at the Makerspace. And you can see here people working, the students and the volunteers working to produce face shields in the space. So we were looking mainly at two technologies and 2 case applications. So the teams were initially really interested in the 3D printing of face masks. So these aren't the cloth face masks that we now wear as standard, but the N95 face masks that offer a higher amount of protection. And people have been looking at ways to actually 3D print these face masks using a filter. And then the other really common type of PPE was face shields. When we actually looked a little bit more at these designs and their potential, we realized that the face masks weren't very suitable for the local context. There were major issues in terms of the actual quality, the fit and the scalability. So 3D printing is a slow technology. So it doesn't work when you need these face masks in their thousands. But what we found was that there was a really promising opportunity for the laser cutting of face shields. And that's where we really focused our efforts in the project. And what was amazing about this was it took a couple of months to get the machines out to field. But once they were out there, the setup time was incredibly quick. So 2 weeks after the machines being installed in the space, there were thousands of face shields being donated to the largest central hospitals in Malawi. And a similar situation in Ethiopia as well. So you can see some more photos here. And this was just really the beginning. So as we said, this project was kick-starting the 20 Makerspace as a capacity for local innovation, for entrepreneurship. So we really were thinking about the short-term needs of the COVID-19 pandemic, but recognizing that the pandemic wasn't going to be around forever. And then what could we do in the future, and how could this benefit the community in the longer term? And through the through the impact that was generated in this project, the team in Malawi were able to secure this further grant from the EU SADC, from EU SADC to actually scale up some of the production of face shields, but also to further expand 20 Makerspace and to take it to its next stage of development. So what we've been doing is trying again to take some of those lessons learned and to share them in a way so that we have a blueprint for how this could be replicated in other places, in other crises, in other contexts. We faced many challenges along the way. So political disruption both in Ethiopia and Malawi. So at one point, the internet was switched off for 6 weeks in Ethiopia, which made communication between the teams very difficult. There was also a change of government in Malawi, which meant there were some delays in terms of getting equipment imported. Material quality was a challenge. All the machinery was imported, but we wanted as much as possible to be able to procure material from the local market. But this was in Malawi, this was a slight challenge because of lack of certainty around some standards. Standards and regulatory approval was a big battle the whole time. We were doing everything very quickly, and it wasn't clear in Malawi and Ethiopia which standards needed to be complied with. So this was actually, we were doing something which was quite new in terms of the development of healthcare equipment in country. And so those standards didn't actually exist. And the way that we got around it was through working closely with Ministry of Health, who granted exemptions because of the nature of this COVID crisis. And then the other thing I just mentioned here is end of life is something that we didn't fully resolve in the project. So these were intended to be easy to clean and reuse. But of course, there's a huge amount of waste or plastic waste that could potentially result from these, the production of this PPE. And that's one angle of the project that we didn't fully resolve and we would like to think more about in the future. So as I said, we've been trying to codify the learnings from this project and really thinking about how you enable this rapid response as part of an iterative cycle of identifying, preparing, mobilizing, and then transitioning to the long-term recovery of the project. We've been thinking about trying to distill what, when, and who needs to be involved in these particular responses. And all of this and more detail about the projects will be published very soon in this rapid response blueprint. So this is a placeholder DOI that should be active next week, hopefully. So thank you very much for listening and look forward to meeting you more.